Unlike the parameters like time constant, bandwidth, etc., which we discussed in the previous lecture, but their discussion was not complete at all. Those terms will come again in later lectures, but the topic which we are going to study in this lecture, which is sensitivity, which will start as well as end in this lecture only, at least conceptually. Otherwise, we can merge this topic with later lecture topics to make a tricky numerical question. Physically, sensitivity defines how well a device or a system, such as a sensor, detects small inputs or changes, for example, the smallest voltage that a system can measure. Mathematically, it is defined as a percentage change in the variable parameter like output divided by the percentage change in the element or a component of the system. Let's try to find out few simple and commonly used sensitivities. First, consider an open loop control system whose transfer function will be equal to feed-forward function. Now, if we have to find the sensitivity of the transfer function with respect to feed-forward function, then first of all, we have to find partial derivative of transfer function with respect to feed-forward function and the ratio of feed-forward transfer function divided by transfer function, which will come out to be equal to 1. Now, the sensitivity will be equal to the product of partial derivative of transfer function with respect to feed-forward function and the ratio of feed-forward function divided by transfer function. After multiplication, we will find the sensitivity will come out to be equal to 1. Now let us consider a closed loop control system in which the transfer function is equal to feed-forward function divided by 1 plus feed-forward function multiplied by feedback function. First, we will try to find the sensitivity of transfer function with respect to feed-forward transfer function. Again, we will first try to find partial derivative of transfer function with respect to feed-forward function. Partial derivative can be easily found by using little bit knowledge of mathematics, which I assume you already have. As knowledge of mathematics is the first important tool that everyone should have before starting any subject of any engineering branch. We can also find the ratio of feed-forward function divided by transfer function, which will be equal to 1 plus feed-forward function multiplied by feedback function. Now we have to simply multiply the partial derivative term into the ratio of feed-forward function divided by transfer function, by doing which we will get the sensitivity of transfer function with respect to feed-forward function to be equal to 1 divided by 1 plus feed-forward system multiplied by feedback system. The same way we can also find the sensitivity of the transfer function with respect to feedback function. We can easily find the partial derivative of transfer function with respect to feedback system, which will come out negative of square of feed-forward system divided by 1 plus feed-forward system into feedback system, the whole being raised to the power 2. In the expression of sensitivity, we have the partial derivative. We will put feedback system as it is. The only term remaining is the transfer function, which we will put quite easily without doing any modification. Cancelling the terms, we will get the sensitivity in the transfer function with respect to feedback system to be equal to negative of feed-forward system into feedback system divided by 1 plus feed-forward system into feedback system. If you can learn these formulas of sensitivity, then it's good, but derivations are actually more important than the direct formulas. These derivations can be asked in academics as well as in subjective competitive exams. I hope you are clear with the properties which are used in differentiation here. Otherwise, you can also check them in the short notes which are attached in the video's description.